Chanchala ma'am, good evening.
Good evening, sir.
How are you now, ma'am?
Sir, I'm fine now. Better.
Yeah. Okay, ma'am. So please start program.
Yes, sir. We're just starting with the program, sir.
Yeah. Yes. Please share. Please continue.
Out of the mountain of despair, a stone of hope. Push yourself because no one else is going to do it for you. A very exuberant evening to one and all present here. Today, once again, we're starting with the 1 week faculty development program on statistical programming SPSS package. Today's session will once again be graced by Dr. Chanchala Jain, ma'am, from Prestige University, Indore. So, ma'am, over to you.
Thank you so much, Shrey, sir. Good evening, all the participants. So today I'm going to take the session on Chi-square test firstly, the non-parametric test. And as because of my health, I haven't taken one more session. So this session would be completed yesterday only. But as I have not taken 1 day session, so now 2 sessions are piled up, and today I'm going to take 2 sessions. I'll complete one non-parametric test today, that is the Chi-square test. Along with that, I'll try to cover t-test, that is the parametric test.
Ma'am, is your video will be available? Will your video available in future, ma'am, for our reference purpose?
I think, sir, YouTube videos are already available. Non-parametric test. So this is the another condition of applying or opting for the non-parametric test. First condition, as I just said, the variable should be on nominal scale or ordinal scale. And the second condition is when the numeric data violating the assumption of parametric test. In that case, we can apply non-parametric test. So all these assumptions we will discuss in case of parametric test when I will discuss the t-test. Starting with the chi-square test. Chi-square test is known as Pearson's chi-square test because it is given by Sir Carl Pearson. So it is also known as Pearson's chi-square test. It is a non-parametric test, that is, it is a distribution-free test. That means when we apply chi-square test on the available data, in that case, we do not need to be bother about the normal distribution of the data. So in that case, we can apply the non-parametric test, that is the chi-square test. Now, using the chi-square test, we are usually finding the association between the two categorical variable. One more thing, when we talk about chi-square test, generally we are trying to compare the expected outcomes or expected data with the observed data, or expected frequency and observed frequency. And in chi-square test, we are trying to find that whether there is any significant difference exists between observed and expected frequency. So whenever we talk about statistics, you will always find this particular terminology, that is significant, because in maths, I think we all know that if I say 4 and 4.5, so we easily say this thing that 4 and 4.5 is not equal in the mathematical term. But when we talk about statistics, in statistics, we will say this thing that whether there is a statistical significant difference in 4 and 4.5. So this terminology is very important. Significant difference means might be possible. 4 and 4.2 can be statistically significant in statistics, but in mathematics they cannot be mathematically significant. So that is the main purpose of using this terminology in statistics. So whenever we are writing our hypothesis, we need to generally use this particular term, significant. So when we will proceed for the chi-square test analysis using SPSS, I'll let you know how to formulate your hypothesis using this particular terminology. Now, we need to, again in this slide, you can read if you are reading this slide. So again in this slide, you will understand that again, this is a repetition of the previous slide. It will tell you that the chi-square test is generally used for the dichotomous scale data, that is the yes or no form data, that is this, it can also be in binary format. And usually when we are having the data in the frequency form, that is the count form, or that is the in the form of numbers, in that case we are performing chi-square test on the data. But if we are having the data in the percentages form, in that case we will not apply the chi-square test, because ratio data or the percentage data will be the form of ratio scale data, and in that case you will not perform chi-square test until and unless the assumptions of parametric test are unfulfilled by the data. Now, talking about the types of chi-square tests. So there are two types of chi-square test. The very first one is the goodness of fit. So in goodness of fit chi-square test, we will have only the single categorical variable, and having that single categorical variable, we want to find that whatever are the categories of that particular variable, we want to see that all the frequencies for those different categories are equally distributed or not. So the null hypothesis for the goodness of fit chi-square test would be that there is no significant difference between the observed and expected count or expected value. Alternatively, we will say that there is a significant difference in the observed and the expected value. Or I can say there is no significant difference between observed and expected frequencies. So this is one in the same thing. In the either way, we can write the null hypothesis for the chi-square test. Now, taking some examples. So say for example, in any particular bag, there are certain number of candies are available, and which are having of which all are having of different colors. So might be possible some number of candies are having red color, some are of green, then blue and yellow types of candies are there in a bag. So in using the chi-square test, we are expected to find this thing that sellers follow the global distribution or not, then equal number of customers visit the shop each day or not. So this way, these are the certain examples which are depending upon the, or which are the examples of goodness of fit chi-square test. Now, talking about the second type of chi-square test. So this is known as the two-way chi-square test. The first one was the one-way chi-square test. The other name for that was the goodness of fit chi-square test. In that we were having only one categorical variable. Second test is the test of association or independence of association chi-square test. So this is known as the two-way chi-square test, because in this particular test we will having the two categorical variable. So say for example, suppose we want to check the gender performance on the basis of the driving test. So here we are having two variable, whether the male and female are passing the driving test or not. So driving test result would be fail and pass, and gender would be male and female. So that way, using these two variables, we can say that we are having two categorical variable, and we want to find the association between the driving test and the gender, and that way this would be the example of independence of association chi-square test. So in this case, the hypothesis can be there are no relationship between categorical variables. That way we can formulate our hypothesis in this form also, and some other way also I'll show you in upcoming slide. So suppose we want to measure whether there is an association between ownership of car and the family type. So here you can see we have two variable. Ownership of car means particular family is having car or not, and what is the type of that family, whether the family is joint family and whether the family is nuclear family. So on the basis of this, we want to find whether is there any relationship between these two. So other way round, we can make this particular research question as whether ownership of car is related to family type, or I can say whether ownership or of car is dependent on family type. So all the three statements or all the three questions are the same, and they are asking the same thing, whether the ownership of car is related to family type or not. So if we are having these three way of questions, so for these three way of questions, how we can formulate our hypothesis? We can see here the null hypothesis in the first case. First case means we want to measure whether there is an association between ownership of car and the family type. So for this question, the hypothesis will be there is no association between ownership of car and the family type. Then second question is whether ownership of car is related to family type. So for this, the hypothesis will be ownership of car is not related to family type. The third question is whether ownership of car is dependent on family type. So the null hypothesis would be ownership of car is independent of family type. So this way, for these type of questions, we can apply chi-square independence of attributes test, and we can formulate our hypothesis in this fashion. Now, in this particular slide, you will see this is again a recap of the things which I have discussed, that when we are having the frequencies, when we are having the nominal or ordinal scale data, that is categorical data, in that case we can apply chi-square test. Now talking about the assumptions of Pearson's chi-square test. So here you can see I have given here the source also, that I have taken these assumptions from this particular study. And according to this study, the assumptions of chi-square test can be individual observations should be independent of each other. Means whatever individual observations we are collecting for the variable, they should be independent of each other. Or in the other way around, if I want to explain you this particular assumption, so the meaning of this assumption is that means we need to collect observation from a individual only once. So that way, if we are collecting the observation from any particular individual or any particular object only once, so that way we would be able to achieve assumption number 1. Second assumption is expected cell frequencies should not be too small. That is, expected cell count should not be less than 5 in 20% cells. Means in more than 20% of cells, if expected count is coming less than 5, in that case, this assumption will be violated. And in that case, we cannot report the chi-square test. And in that case, we need to report Fisher's exact test. So this is the important second assumption is very important, that if in more than 20% of cells, the expected count or expected frequency is less than 5, in that case, we will not report chi-square test. And to check this assumption, when we will apply the chi-square test using SPSS, in SPSS, below the table of the chi-square test, it would be clearly written that in how many or what is the in how many percent of the cells we are getting the expected count less than 5. So it would be clearly written there. So looking at that particular line, we can understand whether this assumption has been achieved by the data or not. Now, when we talk about the independence of attributes, means second type of chi-square test, in that case, there is a terminology, comes contingency table. So contingency table is what? It is a cross tabulation of the two variables. That is why it is also known as two-way table. So one variable we will keep on the row side and second variable we will keep on the column side, and whatever are the categories of both the variables, that we will show in the row and in the columns. And that way the distribution of the frequencies corresponding to the combination of row and column would be written in that particular table, and that way this table is known as the contingency table. Example I am showing you here in the slide. You can see the same which I have just discussed in the previous slides, that if we want to check whether the ownership of car is dependent on family type or not. So again, you can see in this particular table, here we have taken family type in the row, and we have written here that joint family and the nuclear family, ownership of car, yes and no. So we are having total 200 sample size here, and we can see the joint family or the respondent belonging to the joint family, and he or she is having the car. So there are total 34 people. Similarly, the respondent belonging to joint family, but they that particular respondent do not having the car. So there are total 66 people like that. The people or the respondent belonging to the nuclear family and having the car are 55. Similarly, the respondent belonging to nuclear family and not having the car are 45 in number. So that way, in yes category, we can find total 89 people, and in the no category, we can find total 111 people. In the joint family, you can sum this, and we can say that total 100 people are belonging to the joint family and total 100 people are belonging to the nuclear family. So that means we have the respondents 100, those who are from the joint family, and 100 respondents from the nuclear family. So that way, this is the distribution of the car ownership on the basis of the family type. So for this particular table, we can calculate the, or we can find the chi-square test. So this is known as contingency table. Now, if I talk about the chi-square test, so you can look here. The formula of chi-square test is, this is the symbol, this is known as the chi. So this is the chi-square, which is summation of O minus E square divided by E. In some books, in place of O, you can also find FO, and in place of E, you can find FE. O and FO, that is the observed frequency. E and FE, that is the expected frequency. So in case of the contingency table, or in case of the independence of attributes, you need to calculate E, that is the expected frequency or expected count. So the formula would be row total multiplied by column total divided by grand total. And in case of goodness of fit, E would be calculated as total observations divided by number of observations, means the observed frequency sum divided by total observation will give you the value of E. So this way, these are the two different formulae we will use to calculate E if we are performing chi-square manually. And after getting the value of E, this way we can make the manual table of the chi-square test. All the observed frequency are listed here. Expected count, whatever we will calculate, that we can list down here. Then we can find the difference. We can take the square of the difference, and we can divide this square by the expected count, respective is expected count, and that way we will sum this last column, and this will give us the value of chi-square. And then as we have started from today onwards the statistical test, so I suggest everyone, those who are listening me and making their notes, please write. I'm telling you some of the things which are very important here to understand. So those who are writing, they can write down the first thing which I am telling you, the acceptance and rejection rule. You can make the heading, or if you want me also to write, so I will also write along with you. Give me a second. I'm opening my Word. Whether it is visible or not, anyone will confirm me. Word file.
Ma'am, it's visible.
Okay, thank you so much, sir. So I'm writing here acceptance and rejection rule. Firstly, I'm telling you based on manual calculation. Means if we are performing any statistical test manually, in that case, what is the thumb rule? In that case, what we need to do? We need to compare calculated, or I'm writing the complete term, calculated is less than critical or tabulated. If your calculated value is less than, or calculated value is less than critical value or tabulated value, in that case we will accept the null hypothesis. So this is the first rule, which is based on the manual calculation. Vice versa, if your calculated value is greater than critical value or tabulated value, in that case you will reject the null hypothesis. Second rule, which is based on level of significance, that is p-value comparison we will made here. So here, if p-value is less than level of significance, we will reject the null hypothesis. This is the thumb rule. So you can write, these are the thumb rules. So if any one of you have noted down, that is good. If not, you can capture this screen. So this way, whenever you will refer the notes, or after the session, if you want, you can note it down in your notebooks. So this is the thumb rule of acceptance and rejection of the hypothesis. First one is based on the manual calculation. Second one is based on the level of significance, which we are comparing with the p-value. So if p-value is less than level of significance, we will reject the null hypothesis. So this is the thumb rule. Now I'm Coming back to the slides. Yes. So we have reached to this particular point. I have discussed this thing. Now coming next, this is I have already told you. So if we have calculated chi-square, and this is the same thing I have written in the Word file. If calculated chi-square is less than tabulated chi-square, so we will accept the null hypothesis. So question comes from where we can get the table value. So if you will Google, on Google also you can find the table, and here I am showing you this is the table of the chi-square. So you need to have two things to get the table value of chi-square. The first thing is the degrees of freedom, and second is the level of significance. So degrees of freedom in case of goodness of fit would be n minus 1. So if suppose you are having the sample size of suppose 15, so 15 minus 1, 14. So this is the 14, and suppose at the 5% level of significance you are testing your hypothesis. So corresponding to 14 and corresponding to this 5%, you will find the chi-square table value, and here you can see it is 23.685. So whatever is your calculated value, from the tabulated value, you can compare that value and you can make your decision. Now, how we can perform chi-square using the SPSS? So this is the way, these are the steps I have written here, which will help us to understand that how we can find the chi-square using SPSS. So I think this is the case which I want to discuss with all of you, and the same file I think sir has already shared with all of you. So I expect all of you, please read this particular case which we are going to discuss, and we will see for this how we can apply the chi-square test. I think you can read, or do I need to read for all of you?
Not required, madam.
Yeah, okay, sir. I hope everyone has read it. Can I proceed?
Yes, ma'am.
Yeah, so I think you can understand here we are having the various candy colors, and these are the frequencies corresponding to these candy colors. Now we want to find, we want to help the Candy Crush app company that whether these frequencies are equal across all the categories of color or not. This is what we need to check at the 5% level of significance. So for that, firstly, I am coming to the Word file. Here I am making the null hypothesis. So here I am writing, there is no significant difference in observed frequencies of candy colors observed and expected frequencies of candy colors. This would be our null hypothesis, or I can make it like frequencies are distributed uniformly across all candy colors. So this way, this can be the second way of formulating or developing the hypothesis. So this way, both the hypotheses are similar. Now we need to see, or we need to perform the chi-square test. So for that, I request all of you to open the open the sheet. So to open the sheet, I think I have already told you the procedure. If you have downloaded the file, you can open it directly. I am opening my file from the location itself. So this is my file. I hope everyone has opened, those who are performing along. So can I start performing the chi-square? Okay. So you can see I have taken here three things. First one is the color, second one is the frequency, third one is the color one. So there are two ways the data can be presented, or you have the different ways in which you have data you will have. So one way is this, second way is this. Maybe these are the 5 categories. So I'm clicking on this value label. You would be able to see it is showing me 1 means blue, 2 means pink, 3 means green, 4 means brown, 5 means yellow. So means we have total 25 candies of blue color, 20 of pink, 20 of green, 15 of brown, and 20 of yellow color candies. And in the third column, that is the color one, you can find here we have the repetition of blue up to I think 25. Yes, up to 25. And then we have pink 20. So 20 times pink is written here. So likewise, this way again you can have the data. So these are the two different ways in which you will have the data, or you can have the data. Now if you have data in this way, so how you can perform goodness of it, and if you have data in this way, how you can perform goodness of it, that I'll show you one by one.
Excuse
Firstly,
me,
we
ma'am.
will. Yes, sir.
Ma'am, how can we see the name of color in sheet?
Okay, so here you can find the button value labels icon.
Yes,
You can find when you will
yes.
click on this, it will
Okay, okay,
change.
okay. Yes, sir. Yes, sir.
Yes,
Thank you.
yeah. So now I'll go to the analyze menu to perform chi-square test. So I request everyone go to the analyze menu, then go to the non-parametric test, then go to the legacy dialogs, and then select chi-square. Again, I repeat, go to the analyze menu, select non-parametric test, then select legacy dialogs, and then select chi-square, and then click on this. I hope everyone has opened it.
Yes, ma'am.
Yeah. Now, as I want to perform my analysis on the color, so I'm shifting the color variable from the left box to the test variable list box. So this way, from the with the help of arrow, I have shifted my variable here. Now you can see, in case of the goodness of fit chi-square test, we do not need to touch anything to generate the output. I tell you the meaning of these things which are written here. You can see. First thing is at the lower left side, expected range. It is giving me get from data. Means what is the expected frequency range? It is SPSS is asking me or asking us when we are applying the goodness of it using the SPSS. First option is coming as get from the data. So for expected frequency, whatever is the range, we are giving instruction to the SPSS that take that range from the data itself. Or second is use specified range. That means if you want to specify what should be the expected frequency range, that you can specify. But suggested is this, you need to always go with the get from the data. Similarly, talking about the right lower corner, you can see the expected values. So all categories equal. So means whatever is the expected frequency, we are giving instruction to SPSS that expected frequency or expected count should be the equal throughout the categories of the variable. Or if you want to specify the expected count by your own, so that way you can go with this values option, and here you can define for all the categories whatever expected count you are expecting, so that you can define here also. So that way whatever value you will type here, this would be activated, and that way you can add the frequencies here. But I'll again suggest you always go with the expected values for all categories equal. So as you can see, I have shown you also in the PPTs the formula for the E in case of E, that means the expected count. In case of goodness of fit is total of the observed frequency divided by total frequency, total of observed categories. So that way it will give you the expected count. So this is again the same thing, means again this would be, or again the same formula would be applied here by the SPSS, which I have shown you in the slides. So apart from shifting your variable, you do not need to touch anything here. You can only press here OK to generate your outputs. So once you will press OK, I hope those who are performing, they are getting this kind of result. And if you are getting this kind of result, I think you can see or check by your own here that in case of blue, observed frequency or observed number is coming as 1. So throughout all the 5 categories, we are getting n as 1111, but it is not correct, right? Yes? Anyone? Is it correct or not?
No, ma'am.
Yes, it is not correct, because in the data itself, we can see that for the first category, that is blue, we have total 25 frequencies we have received, or total 25 times blue color was touched by the respondents. So that way it is not coming correct. So the reason is reason of this thing is that I'll tell you the reason of this, because in this particular SPSS, I'll show you, if you have written your data in this form and along with that you have mentioned here the frequencies, so in that case you need to weigh your color using this frequency. And how we will weigh the color or categories of color using this frequency? For that, you need to go to the data menu, and then you need to click on the weight cases. So we will weigh our cases here using the weight cases. So I'll repeat, go to the data menu and select weight cases. And then this dialog box will appear of the weight cases. Here you need to select at the right hand side, you can see do not weight cases, but we want to weight cases. So you need to select the second category, weight cases by. Now you can see this is activated, this box is activated. So we need to transfer frequency to the right hand box using this arrow, and then we need to only press OK. Once I'll press OK, you can get a message from the SPSS that weight by frequency, means weighting is done of all the cases by frequency. So now once I'll come to my data view window, you can see at the lower right corner, you can see one message is coming, that is wait on. I hope everyone would be able to see. If not, you need to pay attention on the mouse cursor I am rotating, which is showing you wait on. Those who are performing, they are easily able to see on their own screen. So this way, now color are weight by the frequencies. So now again you need to go to this shortcut handle. You can go to the Chi-square test. You can reset this, and then again you can shift your color to the weight or to the test variable list, and then you can press OK. Once you will press OK, now you can see the different results are coming. So now you can find the observed frequencies are same, which are mentioned there in the SPSS 5. And expected count is 20 throughout all the 5 categories. This is the residual. I have shown you already the manual calculation. That is the residual, means the difference of observed and expected. So this is the O minus E. it is 5, then 0, 0, 0, and -5 and 0. And that way it is coming as the test statistics, that is the chi-square value. It is 2.5. Degrees of freedom is 4. It is n-1. 5 minus 1, 4. Asymptotic significant value is 0.645. And along with that, you can find the assumption of chi-square test. It is showing 0 cells, that is 0% cells have expected count or expected frequency is less than 5. So that means there is no cell in which the expected count is less than 5. And we can check also manually that for all the cells the expected count is more than 5. So this way assumption has of chi-square has also met here. And using this p-value, we can see the p-value is 0.645, which is greater than 0.05. So I have shown you here, we have written that expected, this is the p-value. So in this case, we will reject the null hypothesis, but here our p is greater than 0.05 because p-value is what? It is 0.645, which is greater than 0.05. So we need to, or we do not reject H0, or we can say H0 holds good. So that means we are accepting our null hypothesis, and if we are accepting the null hypothesis, that means we are concluding that the frequencies are distributed uniformly across all the candy colors. This would be our conclusion in case of goodness of it chi-square test for this particular example. So is it clear to all?
Yes.
Okay. Now again coming back to the same file. Now this time again I'll go to the chi-square test, and rather than taking the color, this time you can take the color one. You can shift it color one to the test variable box, and you can press OK to generate the output. Output is generated or not? It's some problem, I think. Anyone who has got the output? You can go to the data menu. Just a minute. I am closing the weight cases.
Now output is generated.
Yes, sir.
Color one table shows them for blue observed value is 100, expected is also 100, and residual is 0. And significant value is 0.645, and chi-square is 2.5, something like that.
Like mine, can you see my output, sir? Like this you are getting?
Yes, ma'am.
Okay, so if you are getting like this, it is correct. I was not getting this. So what I did, I came back to my file, and what I did, I went here on the data menu. Again, I went to the weight cases, and here I have pressed on the reset and then OK. So that way I have removed weighing of the cases, and then I have again applied the chi-square test using this color one. So I have got the similar output as the previous one. So this is the output we have got in the case of the color and the frequency combination, and this is I have got here in case of color one. So same output I have got here, and again the same interpretation we can draw here that
Ma'am,
the
I have a question.
yes,
Ma'am,
sir.
why we always go to this weight option? Without weight option, why we can't get the answer?
In case of first situation, I tell you, sir, here. So this is the case when you are not weighing your cases. Means what SPSS is understanding that we have only 5 categories, 1, 2, 3, 4, 5, and we do not have any other observation. So it is as I'll show you the output again for this output. You can see here the output was this. So you can see these were the 5 categories of color, and SPSS is understanding that only one observation are there. So it is 1 throughout the categories of these colors. So that is why, to make SPSS understand this thing, that along with these categories, frequencies are also written here. So whenever we are having data with the help of, or in this particular format, that means all the categories we have written in one column, and in the second column frequencies are listed. In that case, we need to always weigh these categories with the frequencies to let SPSS understand this thing, that these frequencies, these categories are not only categories, but these are having their frequencies also. So using this only, you can apply the chi-square if you are weighing your frequency, or if you have weighed your categories using these frequencies. So for making means, this is the process in the SPSS, as SPSS is a software and it is not understanding this thing, that these two things are not different. So that is why we need to weight our cases always when we are performing chi-square in this particular format. Okay, sir, is it clear?
Okay, ma'am. So in every question, we have to always give weight to any to relate these variables.
Yeah, sir. But again, please listen me very carefully. What I said. Format should be this. Format means just a bit. Format means, suppose in one column I have written only categories, and in the other column I have written the frequencies, right? So if data is in this form, in that case you need to weigh all your categories, and then you need to get the output. But if you are having the data in this format, in the color one format, because the data is similar, which is written here in these two columns, the same data is written here in this format also. You can see one is blue, and blue is 25 times coming, because this is the frequency. So what I did here, I have written 125 times. You can cross in your file also. One is written 25 times, then two is written 20 times. So likewise, this is the same data, but the representation of the data is in two different way. If data is available in this form, you can directly apply chi-square test without weighing the cases. But if data is in this format, in that case you need to weigh your cases. Is it clear?
Okay, means we have convert individual series into discrete series.
Yeah.
Okay.
Yeah.
Clear now.
So now, this is the way of the performing chi-square test, goodness of it. Now I request all of you to go and open the next worksheet, I think, which is given in the Excel form, based.
Ma'am, can you show once again that step that 25 is converted into 1 1?
Sorry, sir.
There, ma'am. 1 1. This color one. Just how did you convert it from the second table to frequency to color color one, ma'am? Can you show this step again?
Sir, there is no step. You need to only type 1 times, like this.
Okay. Thank you.
Yeah. I think one education of pet data is also shared with all of you. Is it?
Yes, sir.
What is the name of the exact name of the file, sir? Can anyone repeat that? Education and dog owner, right?
Yes, sir.
Yeah. So I request all of you to please open the same file so that we can perform the chi-square independence of attribute, independence of association, or independence of attribute. Open. Open. Can I proceed?
Yes, ma'am. Yes.
Okay. So here, firstly, we will formulate our independence of attributes. So here, Firstly, we will check how many variables are available. So here gender is available, pet ownership is available, and education is available. So suppose I want to find pet ownership and gender are associated or not. So for that, I'm coming here and I'm writing the null hypothesis. There is no association between pet ownership and gender, or I can write pet ownership is independent of gender. So one in the same thing, either you can write your hypothesis like this or you can write your hypothesis like this. So here we are having two variables, pet ownership and gender. So in that case, we will apply chi-square second way or two-way chi-square test, that is the test of association or independence of attributes. So I hope everyone has written this null hypothesis on their notebooks. Now I'm proceeding with the file. So I'll let you know here now how we can perform chi-square independence of attributes. So to perform that, we need to go to the analyze menu. Then we can go to the descriptive statistics and then we can select cross steps. So I repeat here, go to the analyze menu, then go to the descriptive statistics and then select cross steps. Once I have pressed on OK, you are able to see the cross steps dialog box. Now I can shift one variable to the row. Suppose I'm shifting gender to the row. Second variable, pet ownership, I'm shifting to the column. This way, two things I have shifted to the row and the column to create the contingency table. Now you can click on the statistics. Here you need to select or check the checkbox for the chi-square and then you need to press on continue. Then you can press on the cells button and here observed count is already by default selected by SPSS. You need to also click on the expected count and then you can press continue. And then you do not need to touch anything and you can directly press OK to generate the output. So once I'll press OK, I hope you would be able to see the output. So this is the output for chi-square. This is the output for chi-square independence of association. The first table, which is coming for the combination of gender and pet ownership, in that you can see we have total 20 observations. Nothing is the missing value. So the total observations are 20. Now talking about pet owner cross tabulation. So here you can find the gender, male and female, pet ownership, whether the people are having pet or they do not having pet. So this is the first row is the count, which is the observed frequency. Second row is the expected count, which is the observed frequency. This is for the male category. Similarly for the female category. After that, we can see the chi-square test. Now here, firstly, we will check the output. We will check the assumption of chi-square test. It is showing us two cells, that is 50% cells are having the expected count less than 5. But as per the assumption, the count, the percent should be 20% or less than 20, but it is more than 20%. So it is suggesting us, or it is suggested by the literature, that in that case, we do not perform or we do not need to report chi-square result. In that way, we can report the results of Fisher's exact test. So this is the Fisher's exact test. Its value is 0.350, which is the significant value. So if I talk about Fisher's exact test, p value or the significant value, it is 0.350, which is greater than 0.05. If the p value is greater than 0.05, in that case, we need to accept the null hypothesis and we can conclude that there is no association between the pet ownership and gender. Or I can say that the pet ownership is independent of gender. Means there is nothing to do with the pet ownership with the gender of the owner. So this way, this is the conclusion of the this is the conclusion of the independence of association of the chi-square test. Now, anyone? Yes.
Ma'am, yeah, what this second significant value shows,
Which second, sir?
last column, ma'am. It's last column. Fisher
This?
exact test shows as 0.175. This is also significant value. So what it
Sir,
is?
this is for the one-sided. If you have applied for one tail test and second is for the two tail test. So generally, we have applied, generally, it is depending upon your formulation of the hypothesis. So in case of chi-square test, generally we are going for the two-sided test. So you need to generally report this value. Is it clear? Is it clear, sir?
Madam, we use two-tail test for if we compare for from the both right, both the side, right and left side, means greater or less both we compare.
Yes.
But here we अपने ऐसा कुछ लिया नहीं है मैम यहाँ पर तो.
Yes, sir. We haven't taken anything here like that. And in that, usually the hypothesis which I have shown you here, it is showing me that there is no association between ownership, pet ownership and the gender. So in case of chi-square test, generally we need to formulate our hypothesis in this form. So this is generally suggested. We need to report this exact significant two-sided rather than reporting this.
तो इसको अपन इग्नोर कर सकते हैं ना?
Yes, you need to ignore even when you are reporting, because generally, sir, what happens whenever we are applying any statistical test using the software, so they are giving us so many other things also. Probably some of the internal calculations are requiring those things, so they are reporting us so many things. But all the things we cannot report in the papers. So once you will copy this table, suppose I have copied here like this, I have done Control C. I am coming here, I am pasting my table here. Now, what I can do, I can delete whatever information I do not want, like this. I do not want this. So what I can do, I can come here and I can delete this, like this. Similarly, I can delete this column also. So likewise, whatever we want to report to the study or report in the research paper, that only we can keep here. Remaining we can exclude. Whenever you have studied the research paper, you have also observed this thing. Usually all the things are not reported by the researchers in the papers. Only the things which are required according to the journals or required for the research study, only those things we need to report. Remaining we can remove. Is it fine, sir?
Okay.
Okay. So one more variable is available here, that is the ownership, gender ownership. Along with that, one more variable is education. So if you want to check whether the pet ownership is depending upon the education of the owners or not, so that way also in these two variables also you can perform the chi-square test, and that way you can check the results. So I think that you can perform by your own. You are having that data set. Now, can I proceed with the t-test?
Okay, ma'am.
Yes, ma'am.
Sure, ma'am. Go ahead, ma'am.
Yeah. So, I hope slides are visible now.
Yes.
Yeah. What happened? Yes. Now I start with the parametric test, and today I'll discuss the t-test. Tomorrow we will discuss the ANOVA, and then after that we'll discuss the correlation and regression. So today, firstly, I'll discuss about t-test, and I'll let you know that there are t-test is firstly it's a parametric test, because there are certain assumptions which we need to check, like the normality of the data, like we need to check whether the in case of t-test one sample, we need to only check the normality and the outliers available in the data or not. But when we will go for the independent samples and paired samples, so maybe one or two assumptions there would be more, one or two more assumption would be there in case of independent samples and paired samples t-test. But in case of one sample t-test, we have mainly two assumptions. Now, talking about t-test, so firstly we need to understand what is t-test. So whenever we want to find the significant mean difference, in that case we will look at the t-test. So whenever the interest is the researcher is in finding the significant mean difference in the sample from the population or in the various category of the variable, in that case we are applying the t-test. Now there are three types of t-test, or broadly I can say there are two types of t-test, one sample and two sample. In one sample category we are having only one sample t-test. In that we will compare the sample mean from the population mean. And in case of two sample t-test, we are having two types of t-test, that is the independent samples t-test and second one is the paired samples t-test. So firstly I am discussing the one sample t-test. So one sample t-test, as I just said, it is a parametric test. It is also known as student's t-test, and it determines that whether the sample mean is statistically different from mean or hypothesized population mean. So here we need to understand this thing, that in case of one sample t-test, we always compare the sample mean from the population mean. Or if population mean is not available, in that case we need to hypothesize some mean. From that mean we will compare the sample mean. So this is the case of one sample t-test. So in case of one sample t-test, whatever variable we are having, that variable is known as the test variable, and we need to compare that test variable with the test value. This is known as the hypothesized value or the known population value. In case of one sample t-test, or question comes when we will apply one sample t-test. So when the population standard deviation is unknown. Probably when we talk about the theory concept of the t-test, or when we talk about the t-test and z-test. So in the bookish language, I can say it is clearly written in the books. When the population standard deviation is known, in that case we will go for the z-test. But when the population standard deviation is not known, when it is unknown, in that case we will go for the t-test. So this is the case generally when we are having the data and we are not knowing what is the standard deviation of population. In that case, rather than applying z-test, we are applying t-test. And when we talk about SPSS, in SPSS we have only the t-test available and there is no availability of z-test. Now, talking about how we can perform t-test manually. So the manual procedure is, we need to define our null hypothesis and alternate hypothesis. We need to set the alpha value. We need to calculate the degrees of freedom. We need to state the decision. We need to calculate the t statistics. This is the formula of calculating t statistics. We need to state our results, that whether what is the results we are drawing from the calculation, and then we need to state the conclusion, that whether we are accepting or rejecting the null hypothesis. This is the table of the this is the table of the t-test. Using this table, we can get the value of t, that is the table value or the critical value, that we can compare the calculated value of t. Now, talking about the hypothesis of one sample t-test. So here you can look at the screen, you can look at the table. It is showing me, it is showing us that null hypothesis can be mu is equals to x bar. Mu stands for the population mean, x bar is the sample mean. So in null hypothesis, we are declaring that there is no significant difference in the population mean and the sample mean both are same. Alternatively, we are saying that population mean is not equal to the sample mean. So when we are saying it is not equal, that means here two tails are involved, and it is known as the two-tailed test. That means the rejection reason will fall at both the tails of the both the tails of this bell-shaped curve. Now, when I am clearly stating that mu is greater than or equal to the x bar, that is population mean is more than or equal to the sample mean. Alternatively, I'm saying population mean is less than sample mean. So when clearly you are stating the direction, it is known as one-tailed test. And when I'm saying mu is less than, that means it is a left-tailed test. So in that case, your rejection reason will fall at the left tail. When I say that mu is less than equal to x bar, that is population mean is less than or equal to x bar, and the alternatively I'm saying population mean is more than the sample mean, that is again the direction is very clear. So again it is a one tail test, and when mu is greater than, so it is known as right tail test, and the rejection reason will fall at the right tail of this diagram or of this particular graph. So this would be the rejection reason, and remaining whole would be the acceptance reason of the null hypothesis. Now, if we want to formulate the hypothesis in the word form, so I think I have already told this thing, that hypothesis can be, there is no significant difference in the mean sample or the sample mean and in the population mean, or I can say sample mean is significantly less than the population mean, and I can say sample mean is significantly more than population mean. So this way, these are the ways of formulating the hypothesis for one sample t-test, two-tailed hypothesis, and remaining two are the one-tailed hypothesis for one sample t-test. Now, talking about the assumptions of one sample t-test. So the assumptions are the dependent variable must be continuous, means whatever variable or for whatever variable we want to compare the mean from the population mean, that variable should be continuous or numeric or quantitative, or it should be measured on interval or on ratio scale. Second is, this variable should be normally distributed. Generally, exact normal distribution we cannot expect, so it should be approximately normally distributed. And lastly, the observations are independent of one another. So this assumption can be met by collecting data only once from each and every individual. So that way, these are the assumptions of the one sample t-test. Sorry, one more assumption is there, that is the outlier. There should be no significant outliers. So there is a correction. If you are writing, you can write there is no significant outliers available in the variable. So how we can check these different assumptions? I think yesterday I have already discussed, but today I'll tell you. Once we will go on the SPSS, we will check, or we will I'll let you know how you can perform these assumptions and how you can test them. So if we are getting the histogram for our variable like this, so that way I can say that the variable is approximately normally distributed. Box plot is this. This is the depiction of the outliers. So outliers can be either side. It can be either upper side or it can be either lower side of the whiskers. So if this type of outliers are coming, so you can find this is very far from this whisker. So this can be a significant outlier, but these are little closer to this particular whisker. So probably these are not the significant outlier. But one more way when we talk about SPSS, so if the outliers are significant, SPSS SPSS shows those particular outlier using the asterisk sign. Rather than coming these circles, there would be the asterisk sign. So the asterisk signs are the indication that these are the significant outliers in the data. I think this is already we have discussed in the yesterday's session. Now, how to perform one sample t-test? This is the steps which will indicate us that how we can perform one sample t-test using the SPSS. So this is the theoretical concept of one sample t-test. Now we'll proceed to the SPSS for performing the one sample t-test. So for that, I think GPA IQ file was shared. It would be in the Excel or CSV format, I think. So you need to click on the open data here. Then you need to give the location of your file. So here my location is this, and the file is available here. I need to Check it is CSV file. Yes, it's a CSV file. GPA_IQ. I have selected this file. You need to click on open here. Once you will click on open, it will show you the preview of this file, and then you can press next, then next, then next, then next, then next, and then finish. And this file is opened. Everyone has opened it. Do I need to wait?
Yes, ma'am. We are not able to open the file.
Okay. So again, do I need to repeat the process?
Just a bit, ma'am.
Sorry, do I need to repeat?
Ma'am, just a minute. I am finding
Okay.
the file.
Okay. Okay. Can I proceed, sir? Have you opened?
No, ma'am.
Madam, we could not locate the file, madam.
Yes,
Sorry,
ma'am.
sir?
It is showing some notation, ma'am. We are could not able to open that file in our SPSS, it seems. I
Yes.
think all of us are facing the same problem.
What is the error or what is the message you are getting?
The the unencode encoding of the file is not supporting by the text wizard. You can use the data list command to reduce UTF-16 text data file, ma'am.
Okay. So do one thing. You can open the file. Just a minute. The file was at the here. You can open the file like this. Then you can go to the file menu and you can save it in the Excel format, sir, and then open it. I think
Just
you can
ma'am,
save
give
it.
some time, ma'am.
Yeah, I'm waiting, sir. Save as in an Excel format and then close it and then open the Excel file there. Probably that will help you out. Or if still it is not serving our purpose, so then I'll let you know some other way.
Ma'am, till the time it is opening, I want to ask something.
Yes, sir.
Ma'am, I never attended yesterday's session, so कुछ gap हो गया था, so I'm unable to capture everything. So I just want to know कि ये SPSS software जो है, how can I download it from where I can download it?
Sir, you can go to the IBM SPSS website and from there you can download it. You need to make your account there and then you can download it.
Ma'am,
Even
it is
crack
showing
version
like
is available. Crack version is also available.
I
PC.
think
From where?
Subhash,
Get into PC and then after that we have to click on that icon and then automatically you can download it. Even crack version also. Latest.
Sir, can you please share the link from where I can download
Get
it?
into PC, type get into PC on in Google search engine. Right? Google search engine, get into PC. Then again click on the get into PC. Then you will go inner of the get into PC. And there you type on the right hand side, upper side, on the right, you type just SPSS. You will get everything.
Okay, sir. Thank you so much. And ma'am, we are running it on offline basis only, na?
Sorry,
Yes,
sir.
yes. Yeah, right side, you have to type SPSS. Here.
Okay, okay, sir. Thank you so much.
Ma'am, how we have to run secondary data in SPSS? Can you just show the way?
Sorry,
How
sir.
we can secondary data, ma'am. If suppose if I am working on a financial performance, and I say I'm working on a secondary data of a particular, say, profitability of 2 years, then how we have to run that same data on in SPSS, madam? Can you show the way?
Sir, I think this is not, I am going to cover here in this particular workshop. But
Okay.
depending upon what analysis you are carrying on, it is depending on that. I don't know what type of analysis you want to perform. So it is the same way which I am showing you here. So I am not knowing which test tool you want to perform. If you
Okay.
want to perform one sample t-test, so the way it says, if you want to perform independent sample t-test, so that I'll show you. That way also you can perform. So
Yes,
it is
yes, please.
depending upon.
One example you have to take and show us a little example about the financial performance. Suppose
Sir, I do
SPSS.
not have that data. If you have that data, you can share with me.
Yeah, I have the data, ma'am.
Yes.
I'll share. Thank you, ma'am.
Yes, sir.
Ma'am, still I am facing problem here. Error is showing after
Okay.
saving it in
Sir,
Excel
file
form.
is opening or not? File
Ma'am,
is
file is
opening?
not opening. Yes, जैसे मैं file open करने आ रहा हूँ, and then it shows that error accessing to the Excel file, and the file may not be opened by another application. If so,
No.
close it and try.
The .csv file was opening or not? Previous file, was it opening or not?
It is not opening in SPSS.
No, I'm only asking you the simple plain file which I have shared, whether it is opening there or not.
It is opening. It is opening.
So
ma'am.
do one thing, copy all the data, except the heads. Means copy the data like this, right? Done?
One thing. Okay.
Copy from that file, open here a blank SPSS file and paste on that.
Okay, madam.
Done, sir?
Ma'am, just a minute, ma'am.
Hello, madam. The file which you are mentioning, is it a default file, madam?
Sorry?
Madam, the file which you have mentioned, is it a default file, madam?
Default file.
No, whether it is already created file or whether it is a default file, madam.
It is already created file. Sir, done? Problem resolved? Copy paste, I think you can do easily, is it or not?
Yes, ma'am. Yes, ma'am. It's okay to do with the copy and paste, but
Yeah,
we need to
you
be rename the
Then,
variables. ma'am.
yeah,
So,
in that case, you
yeah.
need to come here and you need to define your variables here.
Yeah,
like
ma'am.
this.
That's what it. Yeah.
Yeah.
No, it is showing only heading IQ, gender and concept, not इस तरीके से show नहीं कर पा रहा ये GPA, IQ, gender. So what to do?
No,
Can
no,
you
sir. You
share
have to go
your
to the
screen?
variable view. Yes, ma'am.
Sir, can you share? I think I'm not knowing to whom I'm talking. The person who is facing the problem, I'm stop sharing my screen. That if you can share your screen, that way I think I can help you out. I think it is little difficult for me to understand your problem.
Okay, ma'am. Okay, ma'am. Madam, is it visible, ma'am? My screen?
Yeah. Little. It is visible, but yes.
Ma'am, this is my Excel file.
You have copied, except, sir, do not copy. As I said, do not copy the labels. I have told you already. Yeah.
Is this
Copy only the data. Yes.
Okay.
Yeah. Control C. Come there.
Control C and
Yes. And then yes, open a fresh one. Go to the file, new data. Now paste here. Now go to the variable view and define your variable names. As per the Excel, you can write the names. I think you can stop share, sir. I think now your problem is resolved, right? Locate, sir. Locate, sir. Am I audible to you?
I would
Yes,
request
ma'am.
Lokesh sir to please stop presenting the screen.
Okay, ma'am. Okay.
Yeah.
Now I stop presenting, ma'am. Stop.
Yeah, thank you. Thank you so much, sir.
Welcome.
My screen is visible, I hope, right?
Yes, ma'am.
Yes, yes. So here, firstly, we need to decide upon that which variable we want to take here for applying the one sample t-test. So here I am going with the very easy variable, that is the IQ level of the students. It is given here in the third column. In the third variable, it is the third variable is the IQ variable. So for this variable, I want to perform the one sample t-test. So for performing one sample t-test, firstly we need to check its assumptions. So for checking the assumptions, we need to go to the analyze menu. Then we need to go to the descriptive statistics. Then we need to go to the explore. Again, I repeat, go to the analyze menu, then descriptive statistics, then explore. Click on explore. Shift your variable IQ from left box to the right box, that is the dependent list box. Then click on the plots, and here rather than selecting the stem and leaf, you can select histogram, and also you can select the normality plot with tests. This is the two changes you need to make here on this plots dialog box, and then you can press continue. Yesterday also we have discussed this process, so I think it is not tedious for you now. You can recall this process. This is a revision kind of session now. Even tomorrow also we will do the same practice for checking the assumptions of the ANOVA. You can press continue here, then you can press OK to generate the output. Now, outputs are generated for IQ variable. So we have total 78 observations. No missing value is there. The mean IQ is 108.92. Now, using these, the kurtosis and the skewness value, you can find these values are coming in the range. If you can recall yesterday's session, I said this thing, that skewness should be in between -2 to +2. So it is coming in that range. Similarly, kurtosis should be in between -3 to +3. So it is again coming in that range. So that way we can conclude that the IQ is approximately normally distributed as per our skewness and the kurtosis. Now, going to the next, that is the Shapiro-Wilks test. Here you can find the p-value or the significant value of the Shapiro test is 0.046, which is less than 0.05. So now can anyone tell me if the p-value is less than 0.05, what we need to do? Anyone?
Reject null hypothesis.
Yes, very good, sir. We will reject the null hypothesis. And yesterday I said this thing, that the null hypothesis for this test is that the variable is normally distributed, means the Shapiro test is declaring or separate test is telling us this thing, that the variable IQ is not normally distributed. But looking at skewness and kurtosis, we were able to say somehow this thing, that the variable is normally distributed. Now coming to the histogram, here I am double clicking on this, then I am selecting from this toolbar, I am selecting this distribution curve option. Now I am closing this. Now I am closing the chart editor also. That way you can see the bell-shaped curve on the graph. Now we can compare the tails of this particular graph. So somehow I can say that left tail is little bigger than the right tail. So probably there is little skewness available in the data. Normal or the QQ plot is saying the story about the normality. So these are the various measures which are telling us the normality of the data. So looking at this QQ plot normal line, we can see mostly data is following the normal line, but some of the deviation we can see of some points from this normal line. Now looking or going down, looking at this box plot, we can see at the lower whisker or at the lower side of the whisker, we can find some of these outliers, but these outliers are coming as a small circles. These are not the asterisk sign. So we can say that there is no significant outliers available in the IQ variable, but normality is little dicey. But looking at this particular histogram, some way we can say that the variable is approximately normally distributed, and looking at the skewness and kurtosis also we can say variable is approximately normally distributed. But Shapiro test is not supporting the normality of the variable. So I'll tell you one more thing here, that being a researcher, up to you what thing you want to report in the study. Means whether you want to report normality of your variable using the histogram or skewness and kurtosis or using the Shapiro wheel. So either of the method you can report. Means sometimes it happens graphs can mislead us also, or we are not in a position to properly read the graph. So if suppose you are not able to properly read the histogram, in that case you need to be dependent on this Shapiro wheel test, and that way whatever this test is telling, you will report same thing in your study. So this way you can check the assumption of the one sample t-test. Now how we can perform one sample t-test? For that we need to go to the analyze menu, then we need to go to the compare means, and then we can go to the one sample t-test. So I repeat, go to the analyze menu, then go to the compare means, and then go to the one sample t-test, and then I'll click on this. Now here we are having various variable at the left hand side, but the variable for which we want to perform t-test is the IQ. So I'm shifting this variable from left box to the right box, that is the test variable box. Now under the test value, if I will not pass anything here, it will take the population mean as 0. So generally the average IQ in India is approximate 100. So I'm shifting the test value as the 100, or the population IQ as the 100 I'm shifting. Then you can go to the options. Here the confidence interval percentage is 95. That means the level of significance is 5%. If you want to make any changes, say for example, if you want to test your hypothesis for 1% level of significance, in that case your confidence interval percentage will become 99. So in that case you can make changes from your keyboard and you can make it 99. This is the by default setting of SPSS, and I want to check my hypothesis at 5% level of significance, so I'm not making any changes here. Now missing values, by default option is exclude cases analysis by analysis. So means whatever analysis we are opting for, SPSS will treat missing values according to that. So in case of one sample t-test, if there would be any missing value, so it will remove those missing value from the data while doing the calculation. Although there is no missing value available, so we are going with the by default option. We can press continue, and then we can press OK to generate output. Once I'll press OK, you would be able to see the output. The first table is coming as the descriptive table, which is showing us total 78 observations are there for IQ variable. The mean IQ is 108.92. The standard deviation of IQ is 13.171, and the standard error of mean is 1.491. Talking about the value of t-test and its p-value, so you can see the calculated t is coming as 5.983 for the 77 degrees of freedom. Significant value is coming as 0.000, so it is less than 0.05. So that means we can say that we are not going with the null hypothesis, and we can conclude that there is a significant difference in the sample IQ, mean IQ, and the population mean IQ. So mean difference is what? It is 8.923, because mean of the sample is coming as 108.92. We have set the population mean as 100. So the difference of these two is this. 95% confidence interval of the difference is coming as 5.95 and 11.89. So usually these two ranges, whatever these values are coming, they should be having the same sign. Either they should be negative or either they should be positive for the reliable results. So we can conclude here that there is a significant difference in the sample mean IQ and the population mean IQ. So this is the way we are performing one sample t-test using SPSS. So is it fine? Can I go for the independent samples t-test now?
Yes, ma'am.
Okay, thank you, sir. So for that, I'm opening the PPTs of independent samples. I'll take only the independent sample t-test today, and tomorrow I'll try to include ANOVA. Along with that, I'll try to include paired samples t-test, so that whole whatever we want to discuss would be completed during these 7 days. Now, talking about independent samples t-test. So, as I said, independent sample t-test is the two sample t-test in which we are having the two samples. It is also known as student's t-test. Now, whenever we want to compare two unrelated groups, so here this terminology is very important, two unrelated groups. In that case, we are performing independent samples t-test. When the groups are related, in that case, we will perform paired samples t-test. So the unpaired or the independent groups or unrelated groups we need to have to perform independent samples t-test. The meaning of this is the participants of both the group would be different. Say for example, if we are having one variable, that is gender. So in gender, we are having two groups, male group and female group. And suppose we want to compare the weight of male and female. So it is quite clear that male can be the part of only male group. They cannot be the part of female group. Similarly, the female can be the part of only female group. They cannot be the part of male group. So that way, individuality or independency can be maintained, and that way we can collect the weight of both the groups, and that we can compare using the independent samples t-test. Now, which types of variables we need to have to perform independent samples t-test? So we need to have one dependent variable that is that should be measured on continuous scale. An independent variable should be measured on categorical scale, and it should have necessarily two labels. It should have two labels or two categories. So in that case, we want to compare these two categories for this dependent variable. So in that case, we can perform the independent samples t-test. Say for example, we can have independent variable gender. In that we can have two categories, male and female. Or we can have occupation. In that case, we have two categories, business class people and service class people. So this way we should have only two categories in the categorical variable if we want to perform independent samples t-test. Now, usually this is generally written in the books that generally when the sample size is less than or equal to 30, in that case we need to perform t-test, and if we have the sample size more than 30, we need to go for the z-test. But this is generally a bookish language, as I showed you in the previous discussion for the one sample t-test also. If the population standard deviation is unknown, In that case also we cannot perform Z test. And generally there is a theorem in the statistics named as central limit theorem. This theorem is the crux I am telling you. The theorem says when we increase sample size from 30 to more, so generally the sample is showing us the normal distribution. So this is the theory which is signifying, or this is significantly saying this thing. If the sample size is large, in that case, whatever is the data available, it is generally normally distributed data. We can assume that thing. So that way, rather than performing Z test, we can also perform T test. Now, talking about the hypothesis. So in case of independent sample t-test, as we are comparing two groups, so male group or female group or business class people or service class people, anything. So we can write here that the population mean for the male and this population mean for the female are similar, or it is not similar. So that way it is two-tailed test. If it is greater than equal to and less than, it is one-tailed. Less than equal to and greater than, it is again one-tailed. So if we are talking about two-tailed test, rejection reason will fall on the both of the tails, and remaining reason, the middle reason, would be the acceptance reason of the null hypothesis. In case of one-tailed test, left-tailed test, rejection reason will fall at the left-hand side, and at the right-tailed test, the rejection reason will fall at the right-hand side, and remaining portion would be your acceptance reason of the null hypothesis. Now, talking about the hypothesis of the independent sample t-test, so it can be there is no significant difference in the group 1 mean and group 2 mean, or we can write group 1 mean is significantly less than or equal to group 2 mean, or group 1 mean is significantly more than or equal to group 2 mean. So that way, this is known as first hypothesis is the two-tailed test hypothesis in the word form, in the text form, and remaining two are the one-tailed hypothesis in the word form. Other way of writing the hypothesis of the independent samples t-test, this is the first way, this is the other way, or you can also write in this form also your null and alternate hypothesis for independent samples t-test. Meaning would always remain same. Now, how we can perform independent sample t-test manually? So process is same as the one sample t-test. We need to formulate our null hypothesis, our alternate hypothesis. We need to set our level of significance. We need to calculate the degrees of freedom. This can be the formula for degrees of freedom. Then we need to state the rule, that what is the rejection or acceptance rule of the hypothesis. Then we need to perform the formula, that is the t statistics we need to calculate here. Then you can see here SP is the pooled standard deviation, means if we are saying this thing that we have two groups, that is male group and female group. So combinedly we are calculating the standard deviation. If the standard deviation is not similar, so that way you can calculate the pooled standard deviation that you can replace here to calculate t. And then you can find the, here you can see if the standard deviation of both the groups are different, in that case the degrees of freedom formula will be different. I'll show you when go to the SPSS and will perform independent sample t-test. There you can see we are getting 2 degrees of freedom and values of both the degrees of freedom would be different. So that way we will understand why these 2 degrees of freedom are different. And then you can see this is the table value, which will give you the table value of the t. So to get the t value from the table, we need to have the degrees of freedom and we need to have the levels of significance. So if suppose you have calculated value as, suppose this is an example only. So if suppose calculated value is 1.78 for the 5% level of significance and the degrees of freedom is 12. So for 12 degrees of freedom and 5% level of significance, we can see that table value is 2.179. So we can compare 1.78 from 2.179 and we can easily see this thing that calculated value is less than tabulated value or critical value. So in that case, we will accept the null hypothesis. So this way, friends, we can find the independent samples t-test using the manual calculation. Now we need to look at the assumption part also, that what are the assumptions of the independent sample t-test. The very first assumption is the independent variable should be categorical, that is, it should be either measured on nominal scale or it should be measured on ordinal scale. So this is the primary condition of the independent sample t-test, and whatever variable we are having, it should have the two categories only. If we are having two or more than two categories, in that case we will not perform independent sample t-test, because it is not the capacity of the independent sample t-test to compare more than two categories. Now the dependent variable should be continuous in nature. There is independence of observations. So again, the meaning is similar. If we will collect the response from one respondent only once, this assumption can be met. Then talking about next, the dependent variable should be normally distributed in both the groups. The dependent variable has no significant outliers in either of the group, and the variances of the dependent variable in two groups are equal. So first, second and third, this is only the observations which we can make to achieve these assumptions of the t-test. These two we need to perform individually, and last assumption we can get in the output of t only. So question comes, if assumptions are not meeting, in that case what we can do, we can move for the non-parametric test, and the alternate of the independent sample t-test is the Mel-Whitney-U test. So this is all from the theory point of view of the independent sample t-test. Now I am moving for the performing of the independent sample t-test, and I have opened here the employee data sheet. So I think it is also shared by me, and sir has shared with all of you. So I suggest you to please open the employee data sheet to perform independent sample t-test. Can I start, or do I need to wait for a few seconds?
Ma'am, you can start.
Okay, thank you so much, sir. So firstly, we will check here the assumptions. So before checking the assumptions, we need to decide upon which categories we are taking here for performing the t-test. So here I am taking this salary, that is the current salary, and I'm taking the gender. I want to compare the salary of male and female, and that way we want to perform here the independent sample t-test. So here my hypothesis would be, I'm writing my hypothesis here. The hypothesis would be, there is no significant difference between mean salary of male and female employees. This would be our null hypothesis. So now to check this null hypothesis, we will proceed with SPSS. Sorry, I need to open the employee data set like this. So now, firstly, I think from the hypothesis itself, it is clear which variable is the dependent and which is independent, or which variable is the nominal scale variable and which variable is the continuous scale variable. Can anyone tell me? Yes.
Ma'am, salary is the continuous variable and gender is the categorical variable.
Very good, sir. Thank you so much. Salary would be our continuous scale variable. Gender is our nominal scale variable. So now to check whether salary is normally distributed or not, firstly, I'll suggest all of you, I need to check gender is a string variable here. So we need to make it a numeric variable. Just a minute. Yes. Yes. Just a minute. I made a mistake. I have shared all of you the s.sav file directly. So you people need to take little pain here. I'll suggest you do one thing: open a fresh Excel file and copy the gender column from your SPSS file and paste in the Excel. Can anyone do that for me? I'll guide you also. Just a minute. Like this, I have copied it. Coming to Excel, I have pasted it. Done? Done? Is it clear? Anyone?
Yes, ma'am.
Now you need to select this complete column, press Ctrl H and write M against find what and write 1 against replace with and press replace all. Similarly, write F against find what and 2 against replace with and then replace all. And then press OK and close this. And before proceeding, means coming here in the employee data sheet, now come to the variable view, convert this string into the numeric like this, press OK, OK. And then when you will come, you will be able to see that nothing is there in the gender, it is all blank. So you can take your data from the employee data, copy the values, Control C, and then come here and paste here like this. It is done. Done?
Ma'am, unable to follow the process which you have done in the Excel sheet, ma'am. Could you please repeat once?
Okay. So, okay, I have done a Control Z for you, sir. You can select the column. Done. From the upper, from here, select the column. Press Control H. In the find what, you need to write M. In the replace with, you need to write 1. And then you can press replace all. Done? Done, sir?
Yes, ma'am.
Similarly, in find what, you can write F. And then in replace with, you can write 2. And then you can press replace all. And then you can close this. You can copy it. But before copying and pasting it, you need to come here and you need to set the type of your gender variable as numeric. So you can check and change it and then you can paste here. So that way your file is ready now. Okay, sir. Is it clear?
Yes, ma'am.
Yeah. Now, after doing this, firstly, we need to check the assumptions. So we need to go to the analyze menu. We can go to the descriptive statistics. Then we can go to the explore. Now we can select the gender variable and shift it to the factor list box. We can select the current salary and shift it to the dependent list box. This is the two supplement. These are the two supplying you need to do in the dependent list and the factor list box. Then you need to click on the plots and here Deselect stem and leaf and select histogram and select normal plots with test and press continue. That's all. You can press OK to generate the output. Once you will press OK, you would be able to see the current salary is coming for the gender, that is 1 and 2, male and female, 258 and 216. The male wise current salary description and the female wise current salary descriptive statistics is given here. We are coming down to check whether the salary is normally distributed for both the male and female groups or not. So we can check the separables and its significant value. So we can check for a male, the significant value is 0.000. For female also it is 0.000. Both are less than 0.05. So which is indicating us that the salary is not normally distributed for male group and female group. Going down, looking at the histogram, so it is for the gender one, that is for the male. So we need to double click on this. We can put this distribution curve. We can close this. We can close this also. And that way we can see it is clearly showing that the right tail is greater than left tail. So that means the salary or the current salary for the male employees is the rightly skewed. Is it clear? Is it clear? Hello? Yeah.
Yes, ma'am.
Yes. So it is showing us that here in this organization, the males, those who are getting the handsome money or the good salary, they are very less in numbers. So because as this salary is increasing, and we can see these bars are very small now. Coming down, for histogram, male or the female category, the current salary status is this. So again, we can double click, and I think from the graph itself, we can interpret this thing that salary is rightly skewed for female also. But keeping this distribution curve on this histogram, it is showing us or it is telling us the same story. Now looking at the QQ plot, again it is showing that salary is the rightly skewed for male, salary is the rightly skewed for female also. Going down and looking at the box plot, one, this is for the male category, this is for the female category. So looking at this, we can see this is one extent point is coming. Probably this is the person who is drawing the highest salary in the male category. Similarly for the female category. So these asterisks means here till here we are not getting the asterisk sign. We are getting only asterisk in the male category. So this is indicating us that the significant outlier is available for the current salary in the male category, and also some of the significant outliers available in the female category for the current salary. So although these two assumptions are violated by the data, but for the sake of demo, I'm telling you how to perform independent sample t-test. Or you can take if you want to do this exercise at your home also, you can drop some of the values like the 29 number case you can drop here for the male category, and some of the asterisk sign which you can looking here, that also you can drop here. So that way it can little improve your assumptions. Now, for the sake of the demo, I'm telling you how to perform independent sample t-test in SPSS. So for that, you need to go to the Analyze menu. You can compare. You can click on the compare means, and then you can select independent samples t-test. Again, I repeat, go to the Analyze menu, select compare means, and then select independent samples t-test, and click on this. So once you will click, it will open the dialog box for independent samples t-test. You can shift your gender variable and current salary variable there at their proper places. So current salary is the continuous variable. This would be your test variable which we want to test. So which we are shifting to the test variables box. Gender is the factor variable or independent variable that we can shift to the grouping variables box. Here you need to define the group. So you need to click on this define button because it is activated once you will shift your categorical variable there. So group 1 is the 1, group 2 is the 2, because we have given 1 and 2 only categories. If you are giving 0 and 1, so you can define 0 and 1. I have given here 1 and 2. You can press here continue. Then nothing you need to do here. If you want to see options, you can click here. It is only saying you the same thing. Confidence per interval percent is 95%. So it is indicating that the level of significance is 5%. If you want to make any changes, that you can do here. Then exclude cases analysis by analysis. So it is an independent sample t-test. So if SPSS will find any missing value available in the data, it will remove that data from the particular for particular case. So that way deletion will be made by the SPSS. Then you can press continue. You can press OK to generate the output. Once you will press OK, output will be generated. So now I'm going for the interpretation. So I think so far everyone is with me. Any doubt so far? Can I go for interpretation?
Yes.
Okay. So here first table is coming as the group statistics table. We can find here one for the male. So total 258 males are there, 216 females are here. The mean salary for the male is 41,441.78. For female, it is 26,031.92. This is the standard deviation for the salaries of male and female. Now this is the standard error of mean. So from looking at the mean, as we are comparing the mean salary of the male and female, so looking at the mean salary of both the groups, I think we can get an idea that yes, there is a difference in the mean salary of male and female. But whether this difference is significant or not, that we are testing using the t-test. So for that, you need to come to the independent sample test table. Here you can see at the first section, we are getting the Levin's test for equality of variances. So remember, as I said during the conceptual aspect of t-test, independent samples t-test, when I was discussing these slides, I said that one of the assumptions we will get in the output of the independent samples t-test. So here, this is the assumption, that is the assumption of homogeneity of variances. So for that, you need to check here that the F value is 119.669 and its significant value is 0.000, which is less than 0.05. So I write here the assumption for you, or the hypothesis for Levin's test. So here I am writing Levin's test, and the null hypothesis for the Levin's test is variance is equal across the categories. So this would be the null hypothesis for the Levin's test. So looking at the output of the Levin's test, significant value, it is 0.000, which is less than 0.05. So that means we have to reject the null hypothesis, or we are not accepting the null hypothesis of the Levin's test. So that means we are concluding that that the variance is not equal across the categories. So this assumption is also not met by the data. So in that case, what do we need to do? Here you can see at the extreme left side, there are two rows. First is the equal variances assumed. Second is the equal variances not assumed. So our data is supporting equal variances not assumed, as this hypothesis we have rejected of the Levin's test, which is indicating us that the variance is not equal across the categories. So that means you need to go with this category and you need to report the results of this. So here you can see the t value is 11.688 and the degrees of freedom is 344.262. So remember, again I said the same thing, that the degrees of freedom I have discussed in case of the PPTs, that there would be two different degrees of freedom. In case of equal variances, the degrees of freedom always come in the integer form. In case of equal variances not assumed, it can be in the fraction form also. It can be in the decimal point also. So here the t value is 11.688 and its significant value is 0.000, which is less than 0.05. So we will conclude here that there is a significant difference in the mean salaries of male and female employees. Now, talking about the main difference, so you can find the difference of this 41,000 something and 21,000 something is around this. So this is the main difference. So if we want to say whose salary is more, so here we can say that male is drawing more salary in the organization as compared to the female. This is the standard error of differences, and this is the confidence interval of the lower and the upper tail. So you can recall that one sample t-test I said, as we are reporting these results, so here you need to see in both the lower and the upper value, the sign should be same. So here both are the plus values. So that means these test results are reliable test results. So this way, this is the independent sample t-test from my side. So this is all which I wanted to discuss today. So I hope I have done the justice with the topic for the days. So thank you so much from my side for the day. If you have any queries, now the queries are welcome.
Thank you so much, ma'am, for the wonderful session that you have delivered today. The platform is open for the questions. If anyone is willing to ask questions from ma'am, can please proceed further.
So I think having no more questions, we can proceed towards the closure of the session, ma'am. And again, I really admire your determination despite your health issues, taking such a long session and, sharing your knowledge with the participant across is a real inspiration, ma'am. Thank you so much for sharing your